Hello everyone, welcome to your Chapter 4, Lesson 1 notes on using graphs to relate to quantities. By the end of the day, you'll be able to represent, hopefully you don't resent them, represent mathematical relationships using graphs. And our key idea of the day is what I just said. You can use graphs to visually represent the relationship between two variable quantities as they both change. Let's zoom in on this word, variable. Variable means that it can vary. You look at this variable and you see, oh, there's vary inside. That must be very interesting. Vary means it can change. So when two quantities are changing, when two things are changing, we can use a graph to represent, to give us a picture of what that looks like. For example, my brother is making a house. He's making a playhouse for my nieces. And he's going to do some cuts. He's going to cut a board. And the graph here shows the length of a board as it's cut. Describe how the variables are related at various points on the graph. Okay, so here, if we ever want to figure out what we're dealing with, we can look at the title. We're going to look at different parts of the graph. Here we have the title, and the title tells you like the main idea, what this graph is all about. And then you have two axes. You have this axis, which sometimes we call the x-axis, but we're not dealing with x and y here, so I'm just going to put a little x as a reminder. So we have the x-axis. We have the y-axis. Let's see if I can scoot that over just a little bit. I can, except we're not dealing with x and y. Again, these are just reminders. And then instead of having x and y as our variables, we have two other variables. If we want to figure out what our variables are, we just look at the label on the axes. So our variables are time and length. So your axis is this guy right here also. That guy right there. And then also remember to start at the origin. It's always 0, 0. Where everything extends from, it's the origin. Okay. So the variables here, the two axis titles. Our variables are time and length. This is the length of the board or something, that's fine. And when we look at this graph, it's saying when we start out, our board is this long. And then it stays that way for a little bit when suddenly it gets cut and now it's shorter. And then it stays that length for a while and then we come back and we chop it shorter. And now that board is this long. So that represents the length at that time. And then we cut it again, and then finally at the end of our graph, this is how long our board is. It went from being this long down to this long. Now we don't have any numbers on our axis, it's not labeled, so we can't tell by how much it decreased, but we do know it got shorter. So that's a fun story. Now when we have vertical lines, remember the vertical line, up and down. The vertical line segment in our graph is whenever we had a point like this. What happens there? That's when we cut. So whenever the board is cut to a shorter length, that's what happens when the graph just gets shorter like that. But you'll notice this doesn't happen over a period of time. There's no change in time. There's just a change in length because when you cut something, you slice right through it. So the change is instantaneous. It happens in an instant. So we say the cut is instantaneous. So the same thing would happen with hair. You just chop it short, chop it short, chop it short. Except with hair, it would continue to grow a little bit. It would grow, and then you cut it. and then it would grow, and then you cut it. So that's fun, but boards don't grow. So the length of the board, since we're cutting it, is decreasing over time. The length of the board is constant while you are actually cutting the board, because it doesn't change until suddenly it's different. So during the time shown on the board, how many cuts are there? Well, let's look. 1, 2, 3, and that's it. There are 3 different times the board is cut. And finally, there is board left at the time shown. At the end of the time shown, because there is some board here. So yes, it's there. Hopefully that wasn't too boring. You're not too bored. Also, by the way, the secret word today is historian, like someone who studies history. So that's very exciting. Okay, here we go. It's a match. The table right here shows the amount of sunscreen left in a can based on the number of times the sunscreen has been used. What graph could represent the data in the table? Well, we could just make our own graph and say, okay, well, after 0 sprays, it's got 5, and then after 1, it's got 4.8. But if we had a big graph, that would take a long time. So instead, let's just look at the picture and figure out what story is this telling and how can we match it. So here, the amount of sunscreen, well, you start at 0, and then there's some, okay? And when you look at this change, this is a steady difference. They form a line. So this is a regular change. And at the end, there is none left. It's all gone. It's empty. Okay, cool. Oh, and how many uses are shown? It's 1, 2, 3 uses. Here, let's look at this story. Here, the change is not constant. Each time you use it, you use like more and more and more. It's curved. It's not constant. So change is inconsistent, we can say. And there's some left at the end. We don't end at 0 left. And how many uses are there? 1, 2, 3. There are 3 uses at the end. Cool. And then here, what do we have? Here we've got, well, I mean, we just said it's consistent. It's almost consistent, we'll call it, or constant. So that change is constant. And here at the end, there's a lot left. And how many uses do we have? 1, 2, 3 uses. By the way, what do all these graphs have in common? They all have the amount is decreasing. And they all have kind of the same start. They all start with the same amount. So that's good. Okay, now let's look at our table to figure out what story is our table telling, and does that match, what story matches here. So at 0, we've got 5 ounces of, when we haven't used it, we've got 5 ounces of sunscreen. That's kind of the same. But then when we look at this table, we've got 1, 2, 3 uses. Well, everyone has 1, 2, 3 uses. That's good. But here, it changes by just a little bit. Changes by 0.2. It goes down 0.2. I guess I should make these negative. And it goes down by 0.2 ounces. And look, at the very end, there's quite a bit left. So that does not match our last one, because our last one had nothing left. So that can't be it. And that does not match B either, because there's a little bit left, but the change isn't the same every time. So we'll want to go with C. Ta-da, C. Oh, you guys, I went ahead. Okay, so recap, what we did was, we know that the relationship is represented by a table. We needed a graph to represent the relationship, so we compared the pattern of changes in the table to each graph. And what I looked at, the pattern of changes, I called this a story. We're figuring out what story is being told here. So the amount of sunscreen in the container decreases after each use. That should make sense. It goes down every time you use it. I should put this here so it doesn't look like it's pointing increase. And the amount of sunscreen in the container changes slowly. It only changes by 0.2 ounces, which is not very much. I think the graph should fall since it is decreasing at a slow rate. So we needed a graph with a decreasing, slowly, falling slowly. That's a song. Anyway, there you go. Nailed it. So number C. Looks like a copyright. Okay, finally. That's great. But this is all matching and observing. What happens when we need to create it ourselves? Okay, this would be a good time to put in the what's the secret word question. So, when you looked at our graph, the amount of sunscreen, not the amount of sunscreen that was used, but the amount of sunscreen that's left, which was on the vertical axis of our graph, always depended on the number of uses, which was on the horizontal axis. That's an H, by the way. Okay, so the amount of sunscreen we have depends on how many times you use it. That should make sense, right? So we say, yep, this is what I want. The amount of sunscreen left, whatever's on the vertical axis, that is what goes up and down, we call that dependent, because it depends on the horizontal axis. And because the horizontal axis doesn't really depend on anything, we call it independent, meaning it doesn't depend. Horizontal meaning side to side, vertical meaning up and down. So here's your key idea. This is what you're going to want to remember today. I should make it blue so you don't confuse it with the other thing. When one quantity depends on the other, we make sure to put the dependent variable, switch that, independent first. Put the independent variable on the horizontal axis and put the dependent variable on the vertical axis. Hey, yeah, cool. Also, just a note, time is almost always going to be independent because a lot of things depend on time, but time just keeps going no matter what. So if you have a problem that deals with hours or minutes or weeks or days or something, put it on your horizontal axis, put it on your x-axis most of the time. Okay, one more and then we'll be good. So, this is a true story. My nieces and nephew got a stomp rocket for Christmas, and they've been playing with it, and it's very fun. Yeah. I don't even, I'll have to show you guys pictures or something, because it's really cute. So anyway, so if you have a model rocket, and it rises quickly, by the way, I'm going to highlight the important parts as we go. Okay. So it rises quickly, and then slows to a stop as its fuel burns out. Then it begins to fall quickly until a parachute opens. Wow. After which it falls slowly back to Earth. What sketch of a graph could represent the height of the rocket during its flight? Label each section. So our first step is to figure out what are we talking about. We have a story here. How can we represent this story? Well, it asks you to represent the height of the rocket. So that's one variable. Height of the rocket during its flight will represent the time. So we'll represent height of the rocket and the time. And then we need to look for keywords that describe that relationship. I already did that a little bit as we go. Because our height depends on the time, that means our height is going to be our dependent variable, and our time is going to be our independent variable. So I already have some words about like height. I'm just going to look at some time words real quick. So rises quickly and then slows to a stop and then fall quickly until the parachute opens. After it does that. Okay, yeah, cool. There we go. So now let's look at them. When we say rises quickly, that means that the height of the rocket is it's gonna go pretty fast, right? And then as it slows, it's not gonna rise as fast, and then it slows to a stop, which means it's not changing at all. Then I wrote this too big, so I'm gonna just do that real quick. And we also say that it falls quickly. It begins to fall quickly. Ah! But then the parachute opens. Oh, shoot. Okay, and then it falls slowly back to Earth. Oh, I got ahead of myself. So when the parachute opens, that's going to be a change, falling slowly as it's still going down, but not as fast. And then at Earth means it made it back to Earth. Yay, cool. Okay, so let's start out with our title. What should we call this? Fly Me to the Moon? Rocket Height? Rocket Height. Just kidding, it's Rocket Man. Okay, so our title is Rocket Height. Cool. And the two variables that we're dealing with need to go on our graph. So we're going to make a vertical axis, and then we'll make a horizontal axis. Remember that our independent variable always goes horizontally, and our dependent variable always goes vertically, and that's not exactly vertical, is it? You know what? It might just have to be close enough, you guys. Aha! Nailed it. Okay, cool. Here we go. Okay, so at the beginning, we are assuming that we're on land. This is the height of the rocket. Okay, cool. And then it rises quickly. So it goes up real fast. But then it starts to slow down until it doesn't rise anymore. So here, this is our rises quickly part. And then it slows to a stop. So here, slows to a stop right there where it stops. And then after it goes up, 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 it starts to fall back down and it's gaining speed. It's going real fast. Ah! But then, falls quickly. Got so absorbed in my story. Until parachute opens. Oh, shoot. When the parachute opens, it falls slowly back to Earth. When touchdown. It falls slowly. Okay, guys, I got so absorbed. I'm so absorbed in the story that I didn't label this. Okay, so our two variables are height and time. Time, we said, was our independent variable. So over time, we have the height of the rocket. Now notice that what's happening to our rocket is we've got our ground. Okay, here's our ground. Cool. And here's going to be a really awesome picture of a really awesome rocket. With some fins and stuff. Okay, isn't that great? Now what happens to our rocket is it goes up. We're going to assume there's no wind. It goes up, 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 up. It goes real up, real fast. Slows down, comes down real fast until parachute opens, and then it falls down real slow. Okay, so that was very exciting. This is not the path of the rocket. It's not that our rocket goes like this. It's not going wee. It's just going like, oh no, I broke it. It's just going up, ooh, and back down, parachute. Okay, so we're not representing the direction. We're not representing the temperature. We're just representing the height and the time of a rocket. So there you go. There are two ways to tell a story. Actually, there's many ways to tell a story. Here we looked at the graph based off of words. Here we looked at a graph based off of a table. And the most important thing to remember from the day is that whatever depends on the other thing is your up and down, and independent is side to side. Have a great time on your homework.